Good morning, Algebra 2. We are going to cover Lesson 70, solving radical equations. The lesson practice that we're going to be going over is on page 499. Sorry. And the first thing I want to go over, though, is a term called an extraneous solution. And they're going to go over that in the book. When it comes to square root equations, because that's what radical equations are. So when you see radical, think square root, cube root, etc. And so an extraneous solution is a solution that when we go to solve, we find, but when we plug it back into the original equation, it doesn't work. It produces maybe a negative square root or an error in our calculator, but it's a solution that doesn't, it's not a solution of the original equation. So I'm going to break today's notes up into two parts, solving equations with one radical and solving equations with multiple. So let's start with solving equations with one radical, and we're going to do quite a few because there are quite a few in the book. So part A asks us to solve the square root of 2x plus 3 equals 21. Now, this one's really simple. To solve the square root, I'm going to take the inverse of that. And the inverse of a square root is to square both sides. And so on the left, the square root and squared cancel, and you're left with 2x plus 3. On the right, I'm going to simplify using a calculator. So turn it on. 21 squared is 441. And then from there, it's a simple algebraic equation. So to solve for x, you can think of in your head 2 times what number plus 3 is 441, or inverse of adding 3 is to subtract. And so I'm left with 2x equals 438. And then to solve, we would divide by 2. Sorry, I've kept all my solving in red. And I'm going to write my solution up here. And so if I divide, I get x equals 219. So I'm going to check my solution by plugging it into the original. Is 2 times 219 plus 3 equal to 21? So is the square root of 2? So square root of 2 times 219 plus 3, is this equal to 21? Yes. So our solution works. So x equals 219. So let's move on to part B. We're going to solve, this one is 11 equals the square root of x minus 7. And then outside of the radical, we have a minus 2. So when I am solving, just like in an algebraic expression, my goal is to isolate the x. Well, my goal is the same thing here. I can't move the plus 7 because it's underneath the square root with x. And so I have to keep the minus 7 there. But I do need to move this outside 2 before we start squaring it. So I'm going to add 2 first, so that gives me 13 equals the square root of x minus 7. And now we can talk about the inverse of a square root is to square. And I'm going to do that to both sides. So I get 169 is equal to x minus 7. Sorry. I'm trying to color code so you can see the difference between the solving part and my work. I'm not sure if that helps, but we're going to try it. So I get x equals 176. If I wanted to check solution, does 11 equal the square root of 176 minus 7 take away 2? So 11 equals the square root of 169 minus 2. That gives me 13 take away 2. So yes, that works. So our solution is 176. So let's move on to part C. They want us to solve the cube root of 2x plus 1 equals 0. All right, so this one, the difference here is I have a cube root, not a square root, but I am still going to solve it using the same methods. So I need to isolate my radical, so I'm going to subtract 1. And so there's a little glare and I apologize. So now I have the cube root of 2x equals negative 1. In order to, the inverse of cube root, instead of squaring it, I'm going to cube it. And so I get 2x equals negative 1, right? Because negative 1 cubed is just negative 1 times negative 1 times negative 1, which is negative 1. So now we'll divide by 2, and x equals negative 1/2, or you could put negative 0.5. Up to you. I'm going to go ahead and check my solution. So using Desmos, our calculator, is the cube root of 2 times negative 0.5 plus 1 equal to 0. So using my calculator, I have to hit the 3 for cube, and then I have to enter this x root button, and it's telling the calculator cube root, and then 2 times negative 0.5 plus 1, whoops, it doesn't have, and I have, hold on, I need to enter this differently, hold on, cube, parentheses, forgot my parentheses, 2 times negative 0.5 plus 1, and I got 0. So be careful how you enter it, and so our solution works. So x equals negative 1/2 or negative 0.5. Next, part D. So you can use these notes for homework in the future. You can be doing this along with me. If you're doing this along with me, you're going to be fine in this class. So cube root of 3x minus 4 equals 16. So if you can pause the video, see if you can guess what we're going to do first here. Remember, I have to isolate the root symbol. So I'm going to divide both sides by 4. And I do that so now that I'm left with the cube root of 3x minus 4 equals 4. 16 divided by 4. And I'm trying to get rid of that glare. So from here, now I can raise it by 3, and I'm left with 3x minus 4 equals 64, because 4 to the third is 4 times 4 times 4, or you can use your calculator for that part. All right, so I'm going to add 4. I get 3x equals 68. That is not divisible by 3, so I'm just going to write my answer as a fraction, 68 over 3. And then I'm going to check solution. So is 4 times the cube root of 3 times 68 over 3 minus 4, is that equal to 16? I'm going to do this by hand because I see that these are going to cancel. So is 4 times the cube root of 68 minus 4 equal to 16? Yes, because that's the cube root of 64, and that's 4 times 4. Because the cube root of 64 is, we wrote it right here, 4 to the third is 64, so the cube root is 4. So anyways, this solution works. And you can use a calculator to help you check your solution, or I think after doing the next couple, you'll realize when we need to check our solutions. So the second part of our notes is solving equations with 2 radicals. Okay, so we're going to have more than one radical in these parts. So in part E, it says to solve the square root of 9x equals the square root of 5x plus 2. So this is set up perfectly. I have a square root on each side. I have nothing in front. I have nothing after. I just have two square root symbols. And so this is actually a really simple problem. We're going to raise both sides to the second power. And all we will be left with, let me move that down, is what's underneath. So 9x must equal 5x plus 2. Right? The equal side is stating that both of these must be equal. So then I simply subtract 2. That leaves me with 7x equals 5x. Ooh, interesting. Whoops. What am I doing here? I can't believe I just subtracted 2. Let's pretend that didn't happen. Subtract 5x. 2 and 9x aren't like terms. So I have 4x equals 2, divide by 4, and x equals 2 over 4, or 1/2. And does the square root of 9 times 0.5 equal the square root of 5 times 0.5 plus 2? And I'm going to simply enter using my calculator. 9 times 0.5. Okay, this side gives me 2.12. Let's try the right side, square root of 5 times 0.5 plus 2. And I get the exact same decimal. So I know that my solution works. All right, so moving on to F, they want us to solve the negative 1 times the cube root of 2x equals 3 times the cube root of 4x plus 7. Now, I know I have a negative out here. Totally understand that. It's technically an invisible negative 1, okay? And that is fine because I can cube that. So to solve, instead of raising this to the second power, we raise it to the third power because that is what will cancel or undo the cube root. So I have to raise each of these to the cubic power. So negative 1 cubed is negative 1 times 2x equals 4x plus 7. So hopefully you understand why that negative is still there. So that gives me negative 2x equals 4x plus 7. So I'm going to subtract the 4x. Negative 6x equals 7. Divide by negative 6. So x equals a negative 7/6. And so, again, I'm going to check my solution. So is negative 1 times the cube root of 2 times negative 7/6 equal to the cube root of 4 times negative 7/6 plus 7. Again, I'm going to enter these in my calculator. So negative 1 times the cube root of 2, I should put parentheses, 2 times, parentheses, negative 7 divided by 6. And I get 1.33 or 1.326. And on the right, what is the cube root of, 3, there we go, cube root of 4, parentheses, 4 times, parentheses, negative 7 divided by 6, parentheses, plus 7. And again, I get the exact same decimal, so this works. G asks us to use a graphing calculator, and so we're going to skip, we're going to skip G, and we're going to move on to H. So here we go. They want us to solve negative 1 minus 4x equals the square root of x minus 11. So again, I have a root symbol on each side, but these are a square root, so we're going to raise each side by 2. I'm left with negative 1 minus 4x equals x minus 11. So I'm going to do two things at once. I'm going to add the 4x, and I'm going to add the 11. And I'm going to write what's remaining. I have 10 equals 5x. Hopefully everyone can see that. So then I have x equals 2, because 5 times 2 equals 10. So let's check our solution. And now you're thinking, oh, why? So -1 minus 4 times 2, is that equal to 2 minus 11? So a couple things. I end up with the square root over here of -9 and over here of -9. So it may look like it works, but we are not like, I don't have a value here, so I'm not solving this. I can't write 3i equals 3i. This produces an irrational solution. And so because I have the square root of a negative number, this solution doesn't work. This is an extraneous solution because these produce I, or an irrational answer. Also, your calculator would tell you error. So because 2 is extraneous, there's no real solution to this problem. I know that's kind of confusing, but we're only going to do one more, if that makes you feel any better. We're going to solve x equals the square root of 6 minus 5x. Now, I know I put this under the category of 2, but there's only one radical here, but we're going to solve the same way. We're going to raise both sides to the second power. So I get x squared equals 6 minus 5x. So I'm going to get all of this on the same side. So x squared plus 5x minus 6 equals 0. So you can see what I did. I subtracted 6 and I added 5x. Now I'm going to use the quadratic formula to solve this. Or you can factor, it's really up to you. But this is -6. This is a +5. So 6 and -1 are your factors. So x plus 6, x minus 1. So I have two solutions, a -6 and a +1. But I have to check these. So I'm going to start with x equals -6. Is -6 equal to the square root of 6 minus 5 times -6? Okay, so if I simplify that, I get 6 plus 30. And -6 is not equal to the square root of 36. The square root of 36 is positive. So -6 is extraneous. If I check x equals 1, okay, I'm going to put 1 is equal to the square root of 6 minus 5 times 1. So is 1 equal to 6 minus 5? Is 1 equal to the square root of 1? Yes. So this does not work. This does. So I'm only circling the solution that works. -6 produced a it doesn't work, and the solution isn't true. So for this lesson, for homework, we are going to skip, for homework 70, we're going to skip numbers 11, 16, 17, 20, 24, 26, and 27. Thank you.